Hey guys, welcome back to Builds by Maz. Today we're going to be revisiting this dining table and I'll show you how I built these metal bench legs and the table base. Let's get started. So here's a poorly drawn schematic that'll give you all the dimensions that you'll need. I bought some aluminum flat bar and tubing from metal supermarkets, and I'll have a list of all the materials to use for this project at the end of the video. The first thing you need to do is plan all of your cuts, and then measure out and mark the first one. You'll need to use a saw blade that's designed for cutting non-ferrous metals such as aluminum. I sprayed a bit of lubricant onto the saw blade, and then I was able to use my miter saw in essentially the same way that I would use it for cutting lumber. One thing to note is that metals are designed to be cut at lower RPMs than wood, so one trick you can do is to buy a slightly smaller saw blade than your saw is designed for. This is the blade that came with my miter saw, and you can see that it's a 12-inch blade. And this red blade is the one I bought for the aluminum. It's 10 inches, slightly smaller but still big enough to make a clean cut. I used this first cut piece to line up the marks for the next cuts, which will help ensure that the pieces are the same size. And from there, it's just a matter of cutting out all the rest of the pieces. I chamfered down all the edges that would be joined to other pieces using a metal file. You're basically wanting it to look like this. The reason this is necessary is because we're using a technique called brazing to join the metals together instead of welding. We want to create more surface area along this edge for the filler metal, and you can see here that before filing, the joint is too smooth. Chamfering the edges created this little channel, which the filler metal will run along and result in a much stronger bond. I cleaned up any metal filings with a wire brush, and then it was time to braze. The process of brazing involves heating up the metals to be joined, in this case aluminum, until they're hot enough to melt the brazing rod. Because the melting point of the rod is lower than that of the aluminum, eventually it'll get hot enough that when you run the rod along the surface, it'll melt into the chamfer we created, joining the pieces together. The filler metal needs time to solidify before it can be handled, so leave it alone, and in the meantime you can start working on another joint. The aluminum can take a frustratingly long time to heat up, so I set up this little rig so that I wouldn't have to be holding the torch the entire time. If you're running the rod along the metal and it's not melting, just be patient and keep on heating the aluminum. The metal surface is what needs to melt the rod. Don't be tempted to melt it directly with the torch, or this is what will happen. The rod will just clump up, it won't melt properly and run into the chamfer, and it won't create a bond. I can't emphasize this enough. Do not do this or your joints will fall apart. Compare that to how this looks when brazing is done properly. When the metal is heated enough, the rod will melt on its own, fill into the gaps, and create a very strong bond. You'll need to braze all four edges of every joint together to ensure that it's structurally sound. This is a time-consuming process, and one mistake I made was that I bought flat bar that was too thick, and it took forever for these pieces to heat up enough to melt the rods. At the end of the day, welding is always going to be the preferred option for joining metals. It's faster, stronger, and gives you better results. But brazing is a good alternative if you don't have access to a welder, and all you need to get started is a propylene torch and some brazing rods, both of which are pretty inexpensive. Here's what everything looked like once it was complete. First the smaller bench legs, then the table legs. Here's the table minus the middle brace, which I hadn't installed yet. And then lastly, here's the full table base. I then like to use this JB Weld to help fill in and smooth out all of the edges. You just need to add equal parts of each compound together and then mix it until it's homogeneous. It's very workable like a putty, and you can use it to fill in any gaps or holes that you might have. Just give it about a day to harden, and once it's fully cured you can just sand it down. Here I'm using my angle grinder with a 40 grit flap disc attached. It's important to sand down all the joints until they're smooth so that the finished product will look like one piece of solid metal. I then drilled holes into the flat bar portion of the bench and table legs so that I could attach it to the lumber. I gave everything a coat of this Rust-Oleum aluminum primer, which will help the paint adhere better to the metal. And I really recommend this step for ensuring a good finished look. Afterwards, I finished with 2 coats of this black satin spray paint. I need to take better footage next time of the painting process, but just make sure you use at least 2 coats. Here you can see I marked the positioning of the 5 holes of one of the bench legs. Rather than screwing directly into the wood, I prefer to use these, try not to drop them, these, which are called threaded inserts. It should stay on the instructions, but basically you use a drill bit that's almost as wide as the insert and drill a little hole into the wood. I have this tape here on my bit to prevent me from drilling too deep. Using an Allen wrench, you can then screw these inserts into the hole you've made. There are threads on the interior, so you can screw furniture bolts directly into the inserts rather than into the wood. This helps prevent any damage that would occur if you ever needed to disassemble and reassemble the table. I got these 1.2-inch furniture bolts that match the thread count of the inserts, screwing them all in by hand and then tightening up with an Allen wrench. And that's it. Here's a full list of the raw materials that I used for this project. The total cost came out to be $675. So when netted against the Pottery Barn cost, I ended up saving about $3.7 thousand. And here's the final product. If you enjoyed this video, you can subscribe to my channel and be ready for the next project.